Hello everyone, welcome to the 12th lecture in this series. In this lecture, we are going to study in detail about stack data structure. Of course, like the other data structures which we learned with the previous lectures like linked list and arrays, stack is also an abstract data type, and stack also falls under the category of linear data structure. And the other name for stack is as it's a list with a special quality that we can perform insertion and deletion at the same end. So of course the stack ADT can be implemented using arrays as well as with linked lists, and with this lecture we are going to see in detail how stack ADT could be implemented with arrays. So here you could see what stack actually means. Stack is a list and it has a constraint where we can do insertion and deletion in one specific position, which we call it as the top, or we can say that we perform insertion and deletion at one end of the list if we consider stack to be a list. So by insertion and deletion, we use these terms for linked list, but of course in a stack when we talk of insertion and deletion we would say it by the name push and pop, where push is used to refer to insertion and pop is used to refer to deletion operations. And here you could see an image where we have a stack with 4 elements, and you could see that all the elements are stacked one above the other. And here by this example what you can understand is that 6 is the element that entered first into the stack, and so it is placed at the bottommost position, and followed by that we have 7, 2 and 3. And as of now the element 3 is the one that is added the latest to the stack, and so it is occupying the topmost position in this stack. And so in a stack we always have a pointer named top to point to the topmost element in the stack, or the most recent element that has entered into the stack. And as I was mentioning, we have two operations, namely push and another one operation named as pop, where push refers to insertion, and so here the pointer points to 3, which means that is the element that has been added the latest to the stack. And if suppose I have to do a deletion operation or a popping operation on this stack, then it is clear that the element 3 will leave the stack first. So here we see stack is an abstract data type, and I hope by this time you can recollect the definition for abstract data type, where any data structure together with the operations which we can perform on it, we call it as an abstract data type. So with stack the possible operations on it could be like we can do insertion, we can do deletion, we can check whether the stack is full, whether the stack is empty. So all these become operations that could be performed on a stack, and so we will be learning about how to do each of those operations in the later slides. And there is other name for stack, we call it as an LIFO list. We always call a stack as an LIFO list, where LIFO stands for last in and first out data structure. So as I was mentioning before, in a stack the element that entered into the stack, the last, will be the one that will be moved out of it first, and so we call a stack as a last in first out data structure. And also at times we may even call the stack as a push down store, and but in most of the situations we usually use the term LIFO to denote a stack. And of course stack has a lot of real time applications, and mainly with any program execution. If suppose the program has functions with it, then there lies the underlying usage of stacks there. In order to handle function calls and returns, the data structure that sits behind is stack to handle it. And with compilers, in order to pass any grammars, stack data structure will be used. and normally on a computer whatever expression we submit it for a computer for processing, and the expression will be first converted into a postfix expression, and for evaluating the postfix expression and also for converting an expression from infix to postfix, we will be using stacks. And of course with one of the next lectures we will be studying about applications of stacks, where I will be emphasizing how to do, how to use stacks for converting expressions from infix to postfix notation. So here we see that a stack can be implemented using various ways. We can use arrays for its implementation, we can make use of structures, we can make use of pointers, and we can make use of a linked list or a combination of any of these two. And stack could be either of fixed size or it could be of varying size. So if suppose we are using arrays for the implementation of stack, then of course our stack should be of fixed size, and if in case we make use of linked list for its implementation, then it could be of varying size. Depending upon the application, we may use whether arrays to, we may decide whether arrays to use or linked list to be used. And here you could see we have a stack where I have denoted how to do a push and how to do a pop. Just because it is a LIFO data structure, you could see that both push and pop being done at the same end. So these are the possible operations which we can do on a stack, and of course these are the primary operations which we will be doing on a stack. The first is push, which I said it is insertion of an element into a stack. So we are placing an element at the position pointed to by top, where top is the pointer that always stands at the topmost position on a stack. And another operation which we can do on the stack is peek. So peek is just looking at the item that is at the top of the stack, but we don't try to remove it. So if we just retrieve the value that is at the top of the stack without deleting it, then it refers to peek operation. The other operation which we can do on a stack is pop. So in a pop operation, we literally remove the item that is at the top of the stack, and hereafter the element that is next to the top element would be the one that would be the topmost element in the stack. So here we see some of the main operations or functions associated with stack. So we say that stack is an abstract data type, and so these are the operations that could be done on a stack. So the first one is empty of. So this function is meant to check whether the stack is containing any elements or not. If there are no elements left with stack, then this function would return a value of true. And you could see that the return type of this function is Boolean, and of course I hope you might have learnt with C that if a function has a return value of Boolean, then it could return only two possible values, either a true or a false. And so isEmptyOf function would return a value of true if the stack is empty. The next function is isFullOf. So isFullOf purpose is to check whether the stack has reached its maximum limit. So this function is of use when we make use of arrays for the implementation of stack. As you know, arrays are of array is a static data structure and its size is fixed, and so whenever we do insertion of an element into a stack in which we have made use of array based implementation, we always make a check whether we have reached the maximum capacity of the stack. So we can do insertion as long as we have some empty spaces left on a stack, and if suppose we have exceeded the array limits or the size, then it would throw an error or it would report a message that the stack capacity has been exceeded, or we would say that it is an overflow situation. The next operation which we can perform on a stack is push, and as I said, push is inserting an element onto a stack. So it takes two arguments, one is the stack itself and other one is the item, which is the element to be inserted onto the stack. The next operation is pop. Pop is removing an element from the stack, and so it takes only the stack as its argument. So, whatever element that is pointed to by top will be removed from the stack. We have one more function named clear of S. So, the purpose, its name reveals that we just empty off all the contents in a stack. So, irrespective of whether the stack contains few or more elements, we just remove all the elements from the stack and make it empty. And top of S. So, the purpose of this function is to just do or report the topmost element in the stack. So, top of S is almost the same as peek function, which we learned with the previous slide. And the last function is top and pop. So, here it will just return us the topmost element in the stack, and not only that, it will just remove the element that is at the topmost position. So, it does two functions. One is returning the topmost element and other one is removing it from the stack. So, these are some of the operations which we normally perform on a stack, and so they become part of stack's ADT. So, in this slide I have just presented some sample operations which we normally do on a stack. First is push operation. So, here with the stack named S, I do a push operation of an element named A. So, as such it is we initially consider the stack to be empty, and as soon as I do this push operation, now my stack is populated with one element, and that is A. So, here you could see that A being the bottommost element in the stack. Next, I do a push operation on the same stack, but with a different element named B. Followed by that, I do again a push with a different element named C. So, followed by the A, on top of A we have B and C. Now, I do I have a statement here, D is equal to top of S. So, here top of S just retrieves the topmost element from the stack, but it does not remove the element from the stack. So, here we will have a variable named D that will contain the value that is being pointed to by the pointer named top. So, by this moment C is on the topmost element in the stack, and so D is supposed to have the value of C. After that, I issue a pop operation, which means C will be removed from the stack. And then I do again a push operation with an element named E, and so now the stack would be in such a way that we will have elements A, B and E is the topmost element on the stack. And at last I do again a pop operation. Now E will be removed from the stack. So, now the stack would contain just two elements, namely A and B. So, this is how we do various operations on a stack. So, now we are going to focus on how to implement stacks using arrays. So, in order to implement stacks using arrays, first and foremost we may have to declare an array. Its size could be fixed based on our need. So, here in this example you see an array with size as 4. So, that is what we have denoted as capacity is equal to 4. And initially you could see that the array is empty, and you could see the array indices being 0 to 3. And by the time we initiate the implementation of stack using arrays, we initialize the value for the top pointer to be -1. So, as and when I add a new element to the stack, every time I increment top by 1, and I also make a check whether I have not exceeded the maximum capacity of the array, and followed by that I will be proceeding with adding a new element into the stack. So, the first when we think of implementing stack using arrays, we will declare an array of fixed size, and that is going to be the maximum size for the stack. Whatever the capacity of the array is, that is going to be the maximum size of the stack. After that, we set up a variable named top. The purpose of top is to always point to the topmost element in that array. And in general, top will always carry the value of index. So, whatever element we feel that is at the top of the stack, its corresponding index will be held in the pointer named top. So, that is why we say that top contains the array index of the topmost element in the stack. So, implementing a stack is always easy, that too with arrays it is very easy. So, as you know, at the time of start of implementation, top will have a value of -1. As I add the first element to the stack, it should be added at the 0th index in that array. So, the bottommost element of the stack is supposed to be at the 0th index of the array. And if suppose we fix the size of the array to be num items, in that case the maximum element the stack could contain should be at the index num items -1. So, that will be the topmost, that can be the topmost element of the stack if the stack is full. And I am supposed to do push operations on the stack as long as the array index is less than num items. So, the last element that I can add to the stack would be at data of num items, and I can pop off the stack from the elements. I can pop off some of the elements from the stack starting from num items till I reach 0. So, if I go beyond the 0, then it means I am going out of the bounds of the array. So, which means that is treated as stack underflow. So, we will be seeing more about it during the time we learn with code. So, first we dive into the push operation on a stack. So, the process of adding a new element onto a stack, we call it as push operation. So, these are the steps you should do when we think of implementing a push operation. First, we will check whether the stack is full. If the stack is full, then we cannot proceed with adding a new element onto the stack. So, we should stop there, report an error and just exit. If suppose the stack is not full, then the first I should do an increment operation so in such a way that top gets incremented by 1. So, it means now top points to an empty space in that array. So, in that empty space now I can add the element, and thereafter top will be pointing to the newly added element, and finally we can return a success that the element has been successfully added on to the stack. So, here you have an example. Here you could see that we have an array with 8 locations. So, we can say that the capacity of the array is 8. Here you could see that we have omitted the 0th index and we have started using locations from 1. As of now, the stack contains 3 elements M, N and O, and the topmost element of the stack is O, and so the value of top is 3 as of now. Number of elements in the stack is also 3. And here as you could see that the maximum capacity of the array is 8, the variable max stack should have a value of 8. So, here whenever I do push operation, you could see the function has taken 4 arguments. One is the stack, and other one is the current value of top, and other argument is the maximum capacity of the stack, and the fourth argument being the item to be added onto the stack. So, first I make a check whether top is equivalent to maximum stack size. So, in our case the top value is 3, but the maximum stack size is 8. So, this condition is false. So, which means our stack is not full by this time. So, if suppose this condition is true, then this algorithm would print that an overflow has happened, and so insertion cannot be done. So, if otherwise, first and foremost top would be incremented by 1. So, top being pointing to the third index, now it will point to index 4, and as such we put the item at stack of top, which is stack of 4. So, the new element would be added to the 4th position in this array. and finally it returns. So, we can keep on adding elements to this stack till we reach this maximum limit of 8, after which insertion is not possible as we have used array implementation for stack. The next operation is pop operation. So, pop is used to mean deletion on a stack, and here also deletion happens at the same position where we do insertion. So, since a stack is lost in first out, we do insertion and deletion at the same position being pointed to by top. So, before we proceed with pop operation, first we check whether the stack is empty or not. If suppose the stack is empty, we cannot delete any elements from it just because it does not have anything. And if suppose the stack is empty, then we just say it is empty and report an error and just exit. If it is not empty, then it means the top is pointing to the element that has to be deleted. So, we just remove the element from the top of stack and decrement the top pointer by 1. So, that top now points to the next element following the element that has been deleted now, and finally, we return a success. So, here we can see how pop operation works with an example. You have the same array here with 8 locations, and as of now you could see that top has a value of 2, which means n is the topmost element in the stack now. So, whenever we do a pop operation, this function takes 3 arguments as input. One is the stack itself, other one is the current position of top, and third one is the item which is being deleted from the stack. And first we check whether top is equal to null. So, in our case top has some value which is 2 at this moment, and so it is not null or empty, right. So, we just skip this statement. Next we move to the second statement, which says the element being pointed to by top has to be taken and placed in the variable named item. So, we fetch the topmost element from the stack and put it in the variable named item, and followed by that we decrement top by 1. So, in this case if you want to delete n, then n will be put up in the variable named item, and followed by the top has to be decremented by 1, and after the top will become 1, and finally we do a return operation. So, this is how we perform deletion operation on the stack. So, we can keep on deleting till we reach the last element, I mean the bottommost position on the stack. So, in this case the bottommost position is index 1. So, now we see how to implement stack using arrays with example code. First, let us see how to do declaration for stack and how to create a stack with this piece of code. So, in this example, as you see, we have defined a constant max size with the value 100, and then we are defining a structure named LIFO. The structure has 2 members, one is an array, the name of the array is ST, and its size is 100, and we have another member for this structure which is top. So, as such for stack implementation, we have just put up an array as well as the variable together as members of a structure, and then we have a type def statement. So, we just rename struct LIFO as stack. So, hereafter instead of writing struct LIFO, I could just use the term stack, and I am creating a variable for this structure which is S. So, stack S will create a variable for the structure named LIFO. And on the other hand, we see how to create this array first. So, the create operation or the create function takes a pointer to the structure named stack as its argument, and initially we are just assigning a value of -1 to the variable named top there. So, as I add new elements, I will increment top, and top will have some positive value. So, to start with, top is initialized with the value of -1. Now, we see how to do operations, namely push and pop with this code. So, here we first see the push operation. So, in push we have two arguments, one is the stack itself and the next is the element to be added onto the stack. As I said before, whenever we do insertion on a stack, we just check whether we have not exceeded the maximum limits of the array. So, I just check whether S top is equivalent to max size minus 1. So, we have defined max size as 100, we have defined an array of size 100. So, its index would span from 0 to 99. I am checking whether whether top is pointing to 99th index. If so, we have reached the maximum limit, and if so, if suppose this condition is true, then we just print stack overflow and return with an error message. Otherwise, we increment top by 1. So, S top plus plus will increment top by 1, and we place the element at the position pointed to by top. So, the index pointed to top is denoted by S arrow top, and S arrow st of S arrow top would be the location in the stack where the element has to be placed. So, we place the element in the position denoted or pointed to by top, and just we exit. And if suppose I want to do pop operation on a stack, here you could see just having stack as an argument is sufficient, and you could see that the function has a return value of integer. So, we are just going to return the element that is being removed from the stack, that is why we have fixed the return type as integer. So, first we check whether the stack contains some element or not. That is what we check with this condition, S top equal to -1. If this condition is true, then it means the stack is empty and there is no purpose of doing a pop operation there. Otherwise, what we do is we just fetch the element at the top of stack. So, here we could see it is top minus minus. So, it is a post decrement operation. So, you know how post decrement works. First we fetch the value of S top and that is returned, and after that the value of top will be decremented by 1. So, we have done two steps with just a post decrement operator. So, with this pop routine, what happens is that the element pointed to by top will be removed, and also top will be decremented by a value of 1. And here you could see two functions, namely is empty and is full, which I was telling you before to check whether the stack is full or whether the stack is empty. First, let us see how is empty works. It takes only the stack as its argument and it has a return value of integer. We check whether the value pointed to by top is -1. If it is -1, we return a value of 1, which means true. Otherwise, we return a value of 0, which is false. And the working of is full is the reverse of what we see here. We again it takes stack as its argument. We check whether top points to a value which is greater than or equal to max size. So, in our case our max size is 100, and as I said that we can have values from 0 to 99. So, I check whether the top has a value equal to 100 or something greater than that. On both cases we say that the stack has already overflown, and so return a value of 1, otherwise we return a value of 0. And this is an example program to demonstrate the implementation of stack using arrays. So, here we have defined the maximum size for the array, we have declared a structure which we studied before, and now let us put our attention to the main function. So, the first line we have stack a comma b, which means we have created two stacks a and b, and first we make a call to the function named create, where we pass the address of the structure named A to the create function as its argument. So, by this time what will happen is that A being a structure with two members, one being array named st and another is a variable named top. Within the create function we just initialize the value for top as -1. So, similarly when you call the function create with b as its with the pointer to the structure b as its argument, then what would happen is that we have created one more stack named b, and same as a, here also the value of top would be initialized to -1. Next we do a push operation on the array with the value of 10. So, ultimately this will invoke the push function, and 10 would be placed at the index a of 0. And next again I do a push operation of with the value of 20. So, at index 1 the value 20 would be placed. Again I make a push operation on stack A with the value of 30. So, A of 2 would have the value of 30. The fourth operation is push on the stack named B with the value of 100, which means stack push operation would initially increment top by 1. So, top would become 0. So, B of 0 would have a value of 100. Again I do a push operation on stack B with the value of 5. So, what would happen is that top would be incremented by 1. So, B of 1 would have a value of 5. Then I have a printf operation with two pops on it. One is pop of A and another one is pop of B. So, here stack A has 3 elements with 30 being the topmost element. So, pop A would remove 30 from the stack, and pop of B means 5 is the topmost element on the stack named B, and so it would be removed. So, the printf statement would just output 30 and 5. Now, I do a push operation on A with the element being popped from B. Now, as you know, stack B just had 2 elements, one has already been removed. Now, B is just left with one element which is 100. Now, I do a pop operation on B. So, 100 will be removed and the removed element is pushed on to stack named A. So, as such now stack will contain 100 as the topmost element. So, by this time stack A will have 3 elements which are 10, 20 and 100. Now, we check whether B is empty, and obviously you know B had 2 elements which we have just popped off, and so at this moment B is empty. So, we make a check whether B is empty. So, this function would return a value of true. So, we print that B is empty, and finally, we do return from this function. So, this is how we actually implement stack using arrays. To summarize what we have seen so far, stack is a linear data structure, and it is also a list, and it has a constraint that we can do insertion as well as deletion at the same end. And stack works on the principle of last in first out. So, whatever element we add last to the stack will be the one that will be removed from the stack first. And we have some operations that can be performed on the stack, and these operations make up the stack ADT. One is push, which means adding a new element to the top of the stack. We have a function named pop, which actually removes the element from the topmost position on the stack. We have a function named peek, which is just to look which element is at the top of the stack at this moment. And we have functions named is empty of or is full of. The purpose is to check whether the stack is empty or whether the stack is full. So, is empty of is used to check during pop operation whether the stack is empty or not, and is full of is mainly used during push operation to check whether we have reached the maximum limit of the array. And when we think of implementing stack using arrays, we normally declare an array. We have a variable named top, and top helps us to locate or point to the topmost element on the stack, and of course it keeps track of the index of the element in that array that is going to be the topmost element in that stack. And to start with the implementation, initially the variable top will be assigned a value of -1, and a value of -1 is just to denote that the stack is empty as of now. And there are certain operations, I mean there are certain advantages which we can claim with the stack and being implemented using arrays. One is when we implement stack using arrays, the implementation is quite simple and all the operations can be done very fastly, and so we say that be it push, pop or peek, all of them could be done with at a constant time, and so we say that it is of the order of 1. And when we talk of limitation, just because array is a static data structure and its size is fixed, at times this can lead to overflow if we try to exceed the size of the array, and at times in order to avoid overflow we normally declare an array of huge size, and if in that case if we do not entirely use the array, then in that case that is going to be wastage of space. So, these are some of the limitations of implementing stacks using arrays. So, having learnt how to implement stack using arrays, now let us test our understanding of the concepts which we have learnt so far. One is, what is the main principle of stack? So, you know, stack is a last in first out list. So, that is the principle, that is its principle. The element that came last into the stack should be the one to go out first. And what does peek operation do? You know what peek operation is. It is just peeping into the stack and checking what is the topmost element of the stack at this moment. And how do you check if the stack is full? So, you know the condition. We have a function named is full of. So, here just because we use array for its implementation, we keep track of the maximum size of the array. We know the capacity of the array ahead, and we just check whether we top is pointing to the maximum capacity. If so, we say that the stack is full. And what is the disadvantage of using array to implement a stack? So, you know the disadvantage. The disadvantage is that it is array static, and so at times we may end up in a situation where we want to add some more elements to the array, but we cannot do so just because it is a fixed data structure. And write the sequence of push operations for elements 10, 20 and 30. What will be the value of top after these operations? You know, in this case let us imagine the stack is empty at the time we attempt to make this push operations. So, initially top will be -1, and when I add 10, then I will increment top by 1. So, top will become 0. So, at the 0th index I add the element 10. When I push 20, then I once again increment top by 1. So, top will become 1 now, and there I add the element 20, and once again when I do a push operation with the value of 30, I do increment top by 1 once again. So, top will become 2 now. So, at the end of these 3 operations, top will now have a value of 2. The last question is that if you perform a pop operation on an empty stack, what error occurs? As I said, when the stack is empty, there is nothing left out to be popped. So, here we say that it is an underflow situation, and we say that it is an underflow error. So, that is all with the questions. I hope you would have better understood the concepts of implementing stack using arrays. I hope you might have understood the concepts of implementing stack using arrays very well.